Welcome to this next tutorial in the tutorial series on adding SAP Cloud Application Programming Model projects together with SAP HANA Cloud. In this tutorial, entitled Create HANA Stored Procedure and Expose as a CAP Service Function in SAP HANA Cloud, we're going to see how to further combine SAP HANA Cloud native artifacts with the SAP Cloud Application Programming Model, or CAP, and in particular, seeing how to expose SQL script procedures as service functions. Now, you're going to learn how to create and deploy an SAP HANA Cloud SQL script stored procedure, how to create a service function, which is then implemented via an SAP HANA SQL script stored procedure, and how to use a CAP service exit to implement that service function and tie this all together. The major prerequisite for this tutorial is that you have completed the previous tutorials, in particular the ones where we deployed the initial database artifacts and loaded data into them. Now, we're going to start by creating a stored procedure, and if you did the previous tutorial where we created a calculation view, this part's going to be fairly similar, although a stored procedure is different than a calculation view in that it is not so graphical. It uses coding, programming, and in particular, the programming language SQL script, which is SQL-like, but includes important differences and enhancements. For instance, the ability to have both declarative and imperative logic in it. So we're going to start as we did before by going to the command palette and using the HANA command create SAP HANA database artifact. It's going to start the same wizard, but we're going to choose a different artifact type instead of calculation view like we did previously. We're going to do a stored procedure, or it's actually just called procedure in the list. There we are. Procedure, HTTP procedure. And we need to give it a name. Well, we're going to create a very simple stored procedure that's just going to put itself to sleep for a few seconds and then wake back up. Not the most impressive thing to do in the database, but it's going to allow us to clearly see that our stored procedure is working because it will take however long we tell it to sleep, that many seconds to complete. So it makes it really easy to test and verify that we are calling that stored procedure, because otherwise it would return instantly if we did something wrong. So we'll go ahead and create that stored procedure. And let's go ahead. We see the initial creation wizard has input the procedure template, to create a procedure. It's language SQL script. SQL security invoker. There's two different ways to do security in SQL script. Invoker means whatever database user is calling this will be the one that is used for execution. But then there's a definer option too. And this is kind of neat because this allows you to build stored procedures, and they don't execute by the person that is executing them, actually calling them to be executed, but they're executed in a security context of the original user who created them. This is kind of a way to almost create anonymous procedures that are executing as, say, a power user, but can only do those things that are part of the procedure. We need to add a little something here. Let's see, begin. We're going to use a library, a built-in library. So we're going to say begin using SQL script sync. So the synchronous library as sync_lib, just to give it a name. Now we can actually start writing some logic. This is going to be really simple. We're going to call this sync_lib, and then we're going to call this sleep seconds, and we're going to put it to sleep for 10 seconds. There we are. That's it. That's our whole stored procedure. And basically, we're ready to deploy this into the database again. So we'll just come here to the SAP HANA projects view, and we'll hit the little rocket icon, and this will deploy us to the database. It also tells us at this point if we've got any syntax errors. And it did deploy successfully into the database. All good. I think this is a good time, though, to maybe show you what a syntax error would look like, because HANA isn't checking things until they get deployed in the database. So if I do something like specify a library that doesn't exist, I don't get a syntax error when I save or edit this. It's not till I go to deploy it into the database that we'll see the error message. So let's give this a second to try to redeploy this. And this is how errors come at the HANA native level. It did get an error, and it's basically saying database error, invalid name of a function or procedure. There's no member name, sleep seconds 2 does not exist within that library. So that's how syntax errors appear for HANA native artifacts. So let me go ahead and correct that, and wouldn't actually have to. It's deployed correctly into the database, because when you have a syntax error like that, it rolls back the entire deployment. We had already deployed one successfully, but just to keep everything neat and in sync here, I'll do a redeployment. And you actually see that it sees that my changes are no different than what's already in the database, so it didn't actually do anything on that second one, but always good to check. All right, now we want to see our stored procedure. So just like before with the calculation view, let's open the Database Explorer, and it will open up in another tab here. Yeah, we don't need those windows. Those are left over from the previous tutorial. We can go to the Procedures option, and then we'll see the sleep procedure. And I can just come here and say Generate Call Statement. And that's going to open a SQL console. And this is a pretty simple call statement. We didn't have any input or output parameters, so there's nothing to deal with here. It's basically just a call to that procedure. Now, like I said, the way we're going to know this works is when I execute this, it does not come back immediately. In fact, it should take 10 seconds for it to come back, because that's how long we put the procedure to sleep. So obviously a sleep function is useful if you need to wait for something else to happen in parallel. But in this case, it just makes it real easy to verify that we're definitely executing this, and become apparent once we integrate this into our OData service that is working. And we see that it took exactly 10 seconds to run. There's nothing else going on in the stored procedure. So basically the sleep with very little overhead. All right. Now we need to see how to integrate this into our CAP service. It's not exactly the same thing that we did with the stored procedure, because with the stored procedure, we had to go to the database definition level, the interaction CDS, and we had to create a proxy entity. We don't create a proxy entity for stored procedures or functions, table functions. We're going to directly integrate those into the service layer, because that's the only way that we have executable code. So let's go here instead to the SRV and the interaction SRV. And we want to add it directly here in the definition as a function. A function and an action are executable endpoints defined in an OData service directly. And that's what we're doing. We're adding something that doesn't exist in our data model. We're adding it directly to the service itself. We're just going to call it sleep. We could have named it anything we want. It doesn't have to match the name of our underlying stored procedure. And we're going to say what it returns. We're going to expect a Boolean return. Returns Boolean. There we are. Now, if I were to run my CAP service at this point, I would have the sleep function, but it wouldn't do anything because we haven't implemented it yet. Unlike entities that have a built-in handler, functions and actions don't have a built-in handler. It doesn't assume that there's an underlying database artifact and automatically call it. Whereas our entities and views, it assumes that they are existing database tables or views, and it will perform generated SQL on them automatically. But it doesn't know what we want to do. The CAP framework doesn't know what we want to do as part of this sleep function. And it does not automatically assume that it's a stored procedure. That just wouldn't be very, very safe. We don't know what the end user intended to be the implementation of this sleep function. So what we need is some JavaScript code that the Cloud Application Programming Model can execute automatically when this function occurs. And from that JavaScript code, we could completely implement this function in JavaScript, or we can call down in the database, or we could call out to another system. It's completely up to you how you want to implement such functions and actions. But let's come here to the SRV folder. And what we need to do is we need to name it exactly the same as our CDS file, but with extension .js. And that automagical naming is what's going to match these two things up and cause it to automatically be used as the exit handler for our service. So we'll name this the same, interaction srv.js. And we don't need to add any specification here in the service. Now, there are some options if you don't want to name them the same. You can name them differently, but then you have to add an annotation to the service to tell it what file to execute as its exit handler. By matching the names, we don't need any additional annotations or configuration here in the service itself. If we look at the service handler, it's just an empty file right now. It wouldn't do anything. We need to add some logic to this to even get us started here. So let me go ahead and put this in, and then we'll talk about what it's doing. So first of all, we need the Cloud Application Programming Model as a library in JavaScript. And that's what we're doing here by saying requiring that module and putting it into a constant. That gives us programmatic access to all the APIs that are exposed as part of the Cloud Application Programming Model. Then we're basically adding an implementation handler for our service. That's what we're saying here, CDS, service implementation, for whatever service that this is matched to. We know that it's matched by the name to our catalog service. And then we're saying this on, and we give it the name from the service handler, so sleep. So we're implementing what will happen when the sleep function is called. The rest of this logic is whatever we want to type in here, basically, to implement that. We could put anything we want, but what we're going to do is we're going to call our stored procedure. So we're going to say call sleep, that being our HANA SQL script stored procedure. So we built a query string, and then we're going to tell the Cloud Application Programming Model to run that query, and we're going to await. That means we wait for the results to return. Otherwise, this would be asynchronous. We want to get the results back, although there really isn't any results to get back. Then we're going to log those results, whatever's returned, but then we're going to return true out of our function, because remember, this function is expecting a Boolean, and that's not actually what's coming back out of our SQL script function. It's not returning anything. So we're going to return true. In case there's a problem communicating to the HANA database, we want to catch that as an error. We want to log it, and then we're going to return false in the OData service so that we don't just dump if there's a problem. Okay, we don't need to do a CDS build and deploy, because although we made changes to the service, we didn't change or add entities. Therefore, no views need to be generated. So when you add a function or an attribute or an action, as long as you don't use a complex type on the return or input parameters, then you don't have to rebuild it and redeploy it to the database. So we're able to just run it here again. So let me just start it back up. CDS watch profile hybrid. And it's going to open the test page again. Now, the only thing is, our entities automatically show in this little test page for our service endpoints. Functions and actions do not currently get added to the test page. So we just have to manually type the URL on the browser bar. So I'm going to come here and I'm going to add OData v4 catalog. That's the name of our service. And then we're going to say sleep. Put the params on there because there is no input parameters that we're passing in, so empty. And then we'll just hit enter, and notice it's waiting because our procedure goes to sleep. So it's waiting till the procedure is done executing, because we told it to await the end result, and it completed and it returned true. So we know we called our stored procedure because we saw the wait time. It returned true. It finished our logic and it returned true. And we logged out the results, which there were no results being passed back from that particular stored procedure. So it's just an empty array. Let's actually check and test our error path here. Let's call a procedure that doesn't exist. Let's call sleep 1. Okay. I don't need to make any changes. I'll just come over here and re-execute that. And now we see value false, and it came back right away. So we know that it failed to talk to the HANA database, but yet we caught that error, so it didn't dump, and the user still got a correct response that it was false in calling it. But we also see that the error has been logged to the console here because we said CDS log error, and we see all the error details: invalid name of function or procedure, no procedure with the name sleep1. The line of code and what query generated this. So we get a really nice error handler built into CDS as well. And although it's not necessary, I will change that back just because I don't like leave things in a broken state. And you see every time I change a file here, it's actually automatically restarting the CAP server to pick up those changes. That's the nice thing about running CDS watch. It's watching for any changes and it restarts the server automatically when changes occur. So that's why I haven't had to be stopping and starting this. I can just flip over and immediately test. For instance, if I would come over here again and I'd run it again without making any stop or start to the server, manually, it's taking 10 seconds, so we know that it's working. And the false here, when it comes back, it's returned true. So with these steps, you've now seen how to add an OData function to your service layer, which in turn is implemented via exit handler, and that handler's logic calls an SAP HANA stored procedure, which we built and deployed using the same CAP project that we've been using for everything else. So I hope you enjoyed this overall tutorial series and you have a better understanding of how we can combine both SAP HANA development, particularly native database artifacts, and combine those together with the SAP Cloud Application Programming Model to do hybrid testing all throughout the process, as well as combine it with real production level security so we get as accurate a test as we are developing as possible.